Hello! Today I'm going to read Let's Get Moving. Speeding into the Science of Motion with Newtonian Physics. There's the kangaroo, red kangaroo. Oh, sorry. There we go. Red kangaroo loves to play with her ball. When she throws it up, it always comes down. Sometimes it moves fast, and sometimes it moves slowly. Red Kangaroo wonders why. Dr. Chris will be able to help me, she says. There we go. Red Kangaroo finds Dr. Chris in his lab. Can you tell me what makes things move the way they do? She asks him. Things that move follow 3 rules, Dr. Chris replies. A famous physicist named Sir Isaac Newton discovered these rules. So we call the rules Newton's laws of motion. I want to know these rules, cried Red Kangaroo. Can you please teach them to me, Dr. Chris? Yes, but first I need to teach you 3 very important words that will help you understand Newton's laws. They are force, mass, and acceleration. Let's start with force, says Dr. Chris. Force is any push or pull on something. An example of this is pushing a door open or pulling it shut. So, I am using force when I throw my ball into the air. My force pushes it up, Red Kangaroo asks. Exactly, and gravity is the force that pulls it back down. Dr. Chris responds, gravity is a very important pulling force. Without gravity, everything would stay up in the air. Next, we have mass. Dr. Chris continues. Mass is how much matter something is made of. I get it. The bigger ball has more mass than the smaller ball, Red Kangaroo says. Yes, very good, says Dr. Chris. And we can connect mass to force. Let's throw both balls in the air. The ball with a greater mass will feel more force from gravity. Finally, we have acceleration. This is change in speed, says Dr. Chris. A ball is accelerating if it starts out moving slowly and then goes faster. I understand force, mass, and acceleration, says Red Kangaroo. Am I ready to learn Newton's laws now? Yes, you are. Let's go back to the lab, replies Dr. Chris. Newton's first law says that an object will either stay still or continue moving at the same speed and in the same direction unless a force acts on it. So this ball is not moving and will stay that way unless I push it, asks Red Kangaroo. Yes, when you push the ball, you use your force to make it move, says Dr. Chris. The ball will continue to move at the same speed until my hand or another force, like the wall, stops it. Now let's go on to Newton's second law. This law says that an object with a greater mass will need more force to accelerate it. I pushed both of these balls with the same amount of force, says Red Kangaroo. Does Newton's second law mean the smaller ball will accelerate faster because it has less mass? You've got it, Red Kangaroo, Dr. Chris says, but you can also have them accelerate at the same speed. You would just need to use more force on the bigger ball. We just have one law left. Newton's third law says that for every force that acts on an object, there is an equal force acting in the opposite direction. When I push on you, Dr. Chris, I can feel you pushing back on me, Red Kangaroo says. Exactly, says Dr. Chris, and you feel the weight of your ball pushing back on your hand when you push it or throw it in the air. Thanks for teaching me the rules of motion, Dr. Chris, says Red Kangaroo. Now I can think just like Newton and see his 3 laws of motion whenever I see something moving. Okay, the force, acceleration, gravity, mass, motion, Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, and Sir Isaac Newton. He was a famous physicist who created the laws of motion. Some people believe he understood the force of gravity after an apple fell off a tree and hit him on the head. What do you think? Test it out. Which will fall the fastest? Find 2 balls that are different sizes, like a basketball and a baseball. Make predictions about which one you think has the bigger mass and which one you think would hit the ground first if you drop them. A kitchen or bathroom scale can be used to measure the mass of each ball. If you can't find a scale, you can use your hands and arms to decide which is heavier and therefore has more mass. Drop both balls from the same height at the same time. You may need some help from a friend or an adult. If you can't drop both balls at the same time, use a timer to record how much time it takes each ball to hit the ground. Record the results. Were your predictions correct? Try the experiment again with as many different sized balls as you can find. Now, here's demonstrate Newton's first law. Gather a rock, a piece of cardboard, and a cup. Place the cardboard on top of the cup and the rock on the cardboard. Make 2 predictions. What will happen if you pull the cardboard off the cup slowly? What will happen if you pull the cardboard off the cup quickly? Start by pulling the cardboard quickly. Make sure to pull the cardboard horizontally and not up or down. Record what happened to the rock when you pulled out the cardboard. Did this match your prediction? Now pull the cardboard slowly. Record what happened to the rock now. Was it different from when you pulled it quickly? Did it match your prediction? Explain how Newton's laws make the rock act like it does. What force or forces are causing the rock to act in this way? Try the experiment with different materials, paper, plastic, marble, small toys, to see if the results change. There you go. Thank you, and have a great day. Bye.